4 less than 3, like I said, we're going to kind of leapfrog long division to start. We're going to do synthetic division first. I'll double check on the long division piece, what we need to know for that. So student was repeating this course, showed his friend a much quicker method of returning the above result. His work is shown. And so this is using synthetic division. You can see the stuff that's in common. 3, -7, -9. Well, there's 3 and -7 and -9. What's the 0 for? No? See how that's a cube? That's a 1. The 0 is representing there's 0x squareds. You have to have a place for every, like the 3s, the 2s, the 1s for your degree level. Okay, we're going to go over this. Okay, but just letting you know, the 0 is holding the place for any x squareds. There is no x squareds. Okay, all right, cool. Then so he was showing him how to do synthetic division instead of having to do the thing where you factor it all the way out. So the 1 counts for the remainder. So we're kind of talking about all this stuff already. So the 2 on the left side is representing the value of the variable which makes the divisor 0. I'm going to put a 0. The reason what that means is if I say x plus 2 is a factor, what makes x plus 2 0? -2. So -2 is what we would divide. So it's the 0. You're dividing by the zeros to see if it works. Okay. The numbers 3, 0, -7, -9 in the top row. Those are the coefficients of the polynomial. Remember, 0 is with the x squared because there is none. Okay, you put a 0 for the x squared. The 1 that's circled, that represents the remainder. So that means it didn't come out cleanly. Okay. What's that? The 1 on the end there at the top. We'll talk about what the remainder means, but that means that that 0 is not a perfect 0. The numbers 3, 6, and 5 in the bottom row, okay, those are going to be the coefficient of what your answer is, what you factored out. Wait, the coefficient, not quotient. Okay, the coefficient. Yeah, the 0 represents that. Your answer, we'll talk about all the stuff you're saying. Just focus on, we're being general right now, and we're going to get the details in a bit. Okay, but just stay with me. The coefficient of the quotient. So that's the answer, the quotient. Because we are dividing, right? Synthetic division. We're dividing something out. The quotient is your resulting answer. Can you identify how the sets of numbers 6, 12, 10, 3, 6, 5, 1 are obtained? Yes, they're times by 2. Yep. So 6, 12, and 10 are obtained by multiplying. So up there, the 6, 12, 10 in the bottom. The previous number by 2. We put number sign. Number by 2. They're just trying to spell out the process here. I think if you don't like the verbiage, like we're going to do some examples, okay? So just be patient. But and then the 3, 6, 5, 1 is from adding those. From adding the 2 rows. Okay. All right, so we got an example coming and we'll talk about it. All right, so let's look at this, guys. Right here. This will probably help make some breakthroughs. Okay, so we want to do synthetic division of 2, -3, -8, 15 by the factor of x minus 1. So x minus 1, 0 is 1. So we're dividing by 1. Okay, by the 0. Okay, so here's the steps. Maybe you're a steps person. The first thing you do to start synthetic that people kind of get locked up on is drop the first number. So this 2, you're going to drop down to 2. Okay. Now, we set up before, we multiply it. So we're going to go 1 times 2 and put it in the next box. Now we add it. We add -3 plus 2 for -1. And we do the process again. 1 times -1 is -1. Okay. Then we add that, -9. 1 times -9 goes -9. We add, we get 6. Okay, that's going to be our remainder.
So how come the 1 at the start is not
Because it has to be what makes the 0 of the factor. Yeah. Okay. Okay, so we did the work. That's the work. Now, what does the work mean? Okay, so here I want you, this right here, this part is the quotient. This part is the remainder. So we divided out a factor of x, right? So that means that when we divide it out, we drop the degree. When you divide exponents, you're minusing a degree, right? So what I'm saying is, see how we're x cubed? So what's this going to be? An x squared. It's going to be 2x squared. So understand that. So this right here was an x cubed. So our answer goes to x squared because we're dividing out an x. Does that make sense? So it just goes x squared, x constant. You're saying, well, then what's this? That's right. That's the remainder because if we're out of room now. Does that make sense? So the answer for the quotient is going to be 2x squared minus x minus 9. So when I divide it out, x minus 1, I get 2x squared minus x minus 9 with a remainder of 6. Okay, what do we do with the 6? See how this is written? Remainder over divisor. What were we dividing? True, but this, right? Because we don't want to call it 1. We want to call it the x minus 1, the actual factor. So it's going to be, that's the answer. Okay, so here again, quotient, remainder. It's not too bad. What questions do we have?
why do we have to do that form? Why we do that?
Which form? Oh, well, it's not a special form. So to answer your questions is, one, the main reason we're going to try to divide things eventually is we're going to try to see if things are factors, which x minus 1 is actually not a factor. So that's just this is kind of your answer when it's not a factor. So that's why when you have it's not a factor, this is your answer, which may not be helpful to your situation. We'll talk about that stuff later. But the process of doing it, if you get a remainder, this is how you write your remainder answer. Okay, so it's like, oh, shoot, I got a remainder of 6. Well, this is what it is if I do that. It's kind of like if I say, in math, if I say, well, what's 20 divided by 7? Well, if we do remainders, it'd be 2 with a remainder of, 6, right? 2 remainder 6, which we know if we do decimals, there's actually a decimal part there. So it's just not going in cleanly is the point. So x minus 1 is not going cleanly. So that's how we represent it as an expression that it's not going in cleanly. Does that make sense? Okay. So, but we're going to get to it some more. So let's try this one. Let's just keep going. You guys keep asking this type of questions. It's a good question, Spencer. Keep asking questions. All right, use synthetic division to find the quotient and remainder. So they want us to get a remainder. Okay. So don't forget, you're going to have a 0 where? After the 6, right? To represent the cube. Okay, so when you do this, you're going to do x plus 2 means I'm dividing by minus 2. Okay, I'm going to have 5, -6, 3, 0. Nope, I put 0 in the wrong spot. 0, 3, -2, 1. And you put your bar here. And now what's the first step? Drop the 5. So here we go. -2 times 5, -10. Add. -2 times -16, 32. Add. Kind of big numbers this time. -64. Add. Oh man, 122. So we got some really big numbers this time. Not too nice.
Wait, why do you add 0?
What's that?
Why do you add 0?
Because there's not, see how it goes 5, 4, there's no 3. We have to have a 0 represent the 3. Okay, so it says use select division to find the remainder. So the remainder is -239. Good. Find the values of the polynomial when x is replaced by -2. Okay, so that means of the quotient. So find the quotient. Oh, we have to find the quotient too. So the remainder is -239. So the quotient is 5x4 minus 16x3 plus 32x squared minus 61x plus 120. So that's the quotient. Okay, and then it wants us to find the value of the polynomial when I put a -2 in. So what happens when we put a -2 into the original? Let's look. So when you plug that in, and if you calculate that, guess what you're going to get? Yeah. You're going to get -239. You're going to get that value left over.
So where did that 0 come from in the middle?
Again, the 0 in the middle. Where did that come from, guys? We've done that one twice already. There's no x cubed, right? Okay? All right, so comment on your answers in A and B. They're the same. Okay? So the remainder.
You basically just add the, like, if there's not something here, you add there so that you have a remainder.
What's that?
You put the 0 there, so then you end up having a remainder.
No. This 0?
Yeah.
No, that 0 is just whenever you do synthetic division, every degree has to be accounted for. So if we start at 5, so if, for example, if I want to synthetically divide this, if I wanted to do 3x to the 5th plus 1, I would have to go -2, 3, 0 for the 4 spot, 0 for the 3 spot, 0 for the 2 spot, 0 for the 1 spot, and 1. I have to have, every place has to be accounted for. Okay. That make sense? Okay.
I'm a bit confused, sorry, about dy at the end. It's a +1.
It's right here. We're using this one.
Oh, I just looked.
Yeah,
Why wasn't
this one's the original.
Why do we use the original?
It just says find the value of the polynomial when x is replaced by -2. So they're talking about the polynomial you were given. So they're just helping you make a connection between plugging in -2, getting -239, and how you get that for the remainder when you do it in terms of division.
So technically, by finding the remainder, you're just finding
Not the answer. You're finding the value of -2 in the original equation, yes.
by doing it this way.
Yes. I'm just saying these aren't technically the answer. Like, we're doing the process of synthetic division, and we're finding connections between the original and after we divided it. But we really haven't got an answer yet. I haven't said find the zeros. I haven't said, like, we're kind of exploring synthetic division right now. So don't be locked into that's the answer, okay? So sorry, remainder of x plus 2, let's finish writing this, is the same as the value we plugged in. Okay, so the remainder of the x plus 2 is the same as the value of p to the -2 in the original equation. Negative 239 is matched. Okay. Let's get to this one here, and then we're just got a couple more examples, and that's it. If x plus 3 is the divisor of the following synthetic division, calculate the values of m and p. Okay. So it's kind of making you kind of piece together what's going on here. So for example, see how this is 2m? What would you have to have, like working backwards, what would you have to get 2m? You'd have to have 3m, right? What's that?
Would you be multiplying everything by negative?
Yeah, because it gives you the x plus 2.
Yep, so it'd be negative 3. I was just looking it up. So then, yeah, so you'd be at negative 6, right? And then that'd be 4. And so that 3m equals what? So we can kind of figure out what m is my point, but that's fine. So 12.
Oh, it's got to be like
So does m equal 4 then?
oh, never mind. I see.
So
So n is
yeah, m is 4. So my point is that we put a 12 here, but obviously these added doesn't get you 2m, right? So we know that 12 has to equal that number I put there, has to equal 3m. Just using your algebra skills, right? Because we know if I just erase this 12, negative m plus what gets 2m? Well, it has to be a 3m. So 3m equals 12 then, based on what we were given. So dividing the 3, we now know what m is. M is 4. That tells me, right? Calculate the values of m and p, so we got m done. Yep. And that's right, because right here this would be negative 4. Because you put the 4 in, right? What? Oh, n's 8? Okay. So then, yeah, because then, so n is 8. Yep, you guys are right. So n is 8 because 2 times 4 goes there. 16 plus 8 is... Oh, yeah, I forgot times, didn't we? Oh, yeah, negative... So, no, n is not 8 yet. N is negative 24, yeah. Yeah, because it's going to be 8 times negative 3. So 16 plus a negative 24, that's going to be negative 8. So p is negative 8. Good. I worked through that, guys. Good job. So again, that's probably a good diploma question. They put the variables there. They're trying to mess around with you, making sure you understand the algebra piece. But again, I think we can all agree there, the math's not hard there. It's the comprehension, right? It's reading through the question, trying to figure out what they're asking. Okay, all right, I got one more page, guys, and we'll call it a day. 2 examples. All right, when 2x cubed minus 4x squared plus ax plus 3 is divided by x plus 2, the remainder is 3. Determine the value of a. Okay, so x plus 2 means I'm dividing by negative 2. So then I go 2, negative 4, a, and 3. We know we're going to get a remainder of 3. Okay, so let's work through this and see what happens. Drop the 2. Negative 2 times 2, negative 4. Negative 8. 16. Oh, not 16, that's not a 9. Sorry, I was going to add that and make it 25, so that's good. A plus 16, right? We have to write, we don't know what A is. Now times by negative 2, we get negative 2a minus 32 is here. Got to distribute the negative 2, right? And we know this. 3 plus a negative 2a, whoops, minus 32 equals 3. Right? 3 plus this should equal, which you can kind of see what's going to happen, yeah? Well, yeah, you solve for a, but like, does anybody see what's going on? Yeah, Keegan sees it. This is going to be equal to 0, right? 3 plus 0 equals 3. So you can kind of just say, oh, that means this negative 2 times a negative 16 and put a positive 32. So I'm going to get positive 16. or negative 16, okay, but we can do it. So if you go minus the 3 now, you're going to see it now, equals 0. Negative 2a equals 32. A is negative 16 when you solve. Okay. All right, so last thing we're talking about is dividing by not simple zeros, so 2x plus 1s or 3x minus 2s. Okay, so using synthetic division to determine the quotient and remainder when the polynomial is divided by 2x minus 1. So remember, the 0 of 2x minus 1 is 1/2. So that means we have to put a 1/2 here. Okay, so it's not a whole number. That's how it is. And so we still do everything normal. Drop the 2. 1/2 times 2 is 1. 1 plus 1 is 2. 1/2 times 2 is 1 again. 3. Half of 6 is 3. Negative 1 and 3 is 2. So that's your remainder. So your quotient is 2x squared plus 2x plus 6. Your remainder is 2. Except for the problem with that is, the thing we have to change on this, so that's my fault, I shouldn't have wrote that yet. I got to show you. What are you guys thinking in terms of what's different compared to what we just did? Say that again. Right, you didn't go to what you're dividing by. Okay. So if you look over here, this kind of proves it a little bit. dq plus r. So see how we have x to the minus 1/2? We really don't have that, right? What are we dividing by? The 2x minus 1. So what they did was they times this whole thing by 2. So they're pulling a 2 out. So what I'm saying is 2x minus 1 versus x minus 1/2. The difference is this thing is multiplied by 2. Do you see that? Do you see how all these have a 2 in common? So we need to divide that by 2 to actually get the quotient. Because, see right here, 2x minus 1 is a factor. Right. So it's going to be, this is all right. The 2 is right. We just need to divide these by 2. Okay. So think about it in the sense that this is a good illustration. Do you see? See how they all have 2 in common, right? So we can pull a 2 out. You guys can do that. And if I take that 2 and I times it to this, it'll give me what the actual factor was. Okay? That's what's happening. Okay, some of you guys are shaking your head. You're very confused. That's okay. You need to ask a question, but let me show you one more time. Okay.
I don't understand why you have to do that. If x equals half, you don't need to pull the 2 out because x equals half.
Okay, but the problem is that the factor, so when they tell us a factor of 2x minus 1, that means that in our answer we should have a 2x minus 1. You're doing work with it written like this, because if we want to know what the 0 is, right? This x minus 1/2, these are essentially the same thing in terms of the 0. Okay, but in terms of factors, they're different because this one has multiplied by 2. So we're just taking the 2's that we get here, and we're just moving it back into here so we get what they told us to look at. These all have a 2 in common, right? So essentially that's what you can think about. I can pull a 2 out. That's what they did here. The 2 went back into here, so it looks like what they told me to factor out. Okay, yeah.
So when they say you need to divide by whatever, you should have that in your factor.
Correct. Yes. Right. Because you're factoring that out, so that's a factor of your product. Yep. Okay. All right. So we'll look at that. We'll keep looking at that. Like I said, this was going to be a section about practice. Last one. All right. So this is going to be similar. So we have 6x cubed minus 8x squared minus 5x plus 5. There's no gaps or zeros. 3, 2, 1, 0. Okay. So this is going to be negative 2/3. We'll see. I got to see what the end product's going to be, but You mean that we multiply? Yeah, so we're changing it to look like this. X minus 2/3, so it's going to be a 3. Right? Because if I multiply this by 3, it's going to give me 3x minus 2. Bing, right, or 3x plus 2, yeah. Sorry. But see my point? So that we're expecting from the last problem, we hit everything with a 2. This is probably going to hit everything with a 3. Watch what your answer is going to be. You'll see it. Okay, so let's look. Negative 2/3. Let's get going here. So we got negative 2/3. We got the 6. We got the 6. We got the negative 8. We got the negative 5 and the 5. Drop the 6. Negative 2/3 times 6 is a negative 4. Negative 12. Negative 2/3 negative 12 is 8. If you don't see that right away, you can do it with your calculator, but it's just fraction work. Negative 5 plus 8 is 3. 3 times negative 2/3 is negative 2. That gets me a 3. That's my remainder. Okay, so now check it out. We have, as of right now, what this means. Okay, you have it set up like this. Or 2/3, sorry. And then you have 6x squared minus 12x minus 5. See how, 5, why am I saying 5? Sorry, it's 3. Ruined my whole point. Okay, those all have 3's in common. So when we pull that 3 out, I'm doing just like the book did. This will give me 2x squared minus 4x minus 1. That 3 pops in here to give us this look, which we're supposed to have out in front, like I was telling Leah. Because I multiply this into there, which you're not going to have to do every time. You're going to understand. Like that. We still have a remainder.
And your remainder just stays 3?
Yeah, it stays plus 3. It's kind of left out here on its own. See how it says dq plus r? So we just put plus r, because this is the form they're asking for. So that's also just reading what they're saying. Yep.
Why is the 3 that's a constant negative?
This one?
Yeah.
Yep, that should be positive. Okay, good, thank you. So this one's positive, sorry about that. So that means we have a positive 1 here and a positive 1 here. Good. Anything else? Okay, perfect, we're done with that. All right.